Good evening, my dear students. Today we are going to discuss about class 9th, chapter 9, force and laws of motion. In this chapter, we will discuss about force and its units, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and about inertia. So, first we are going to discuss about force and its units. So, what is force? Force is a push or pull. If there is an object, if I push this one, then there is a motion in this body, and if I will pull this object, then there is also a motion in this body. And if the body is moving like this and I will apply a force like this, then the force will oppose the body and the body stops there. So we can write the definition of force, that force is a push or pull which can cause motion inside a body or can stop a moving body. So from this definition we are clear that force is the push or pull which can create a motion inside a body and can stop the body if that body is in motion. Okay, clear? Then we are going to discuss about what are the units of force. So we will discuss about SI unit first. We know there are many types of unit systems: CGS, MKS, FPS and SI. So the SI unit of force is Newton, or we can write this as capital N. Okay, and the CGS unit of force we can write dyne, and there is a relation between this SI unit and CGS unit, that 1 Newton is equal to 10 to the power 5 dyne. Okay, so 1 Newton of force in SI unit is equal to 10 to the power 5 dyne in CGS unit system. So force can change the motion, direction and size of a body. If there will be a sponge, do you know about sponge? If I will press the sponge, pressing means I am applying some force on the sponge, the size of the sponge decreases. If I pull my hands, then the size of the sponge will increase. So the force can change the shape or size of the object, and it can produce a motion and direction also. If this body is moving like this and I will give a force in this direction, then the body will move like this. So force can change the size, shape and direction of an object. Next, a question comes, what is 1 Newton? There is a question, what is 1 Newton? We know force is equal to mass into acceleration. So force is equal to mass into acceleration. Okay, if we know that force unit is 1 Newton, 1 Newton, okay, force equal to 1 Newton. If mass of a body is 1 kg and acceleration of the body is 1 meter per second square, if mass is equal to 1 kg and acceleration is equal to 1 meter per second square, then how we can define 1 Newton? 1 Newton means force is equal to mass is 1 kg, 1 kg into acceleration means 1 meter per second square. So meter per second square. So you can define 1 Newton as if we'll apply a body of 1 kg, if we'll apply some force on a body of 1 kg and if it will move 1 meter per second square, then we can say that 1 Newton of force is applied. Now we are going to discuss about types of forces. We know there are so many types of forces: frictional force, gravitational force, okay. So but force is divided into only two categories. First category is balanced force, okay, and the second category is unbalanced force. Okay, force is divided into two categories. First is balanced force and next one is unbalanced force. What is balanced force then? If a body experiencing some force and the resultant force is equal amount of that force, then we can say that is a balanced force. So let us take an example. If there is a table, I will place a mass or I will place any object over here. Then we know that gravitational force acts continuously towards down. That means gravitational force is like this. And if the body is in rest, that means the resultant force is acting like this. So if the resultant force is 0 or the body is in rest, that means we can say that is a balanced force. So what we can write? If the resultant force is 0, if the resultant force is 0, then it is called balanced force. Okay, what will happen in balanced force? If a body is in rest, that means the body will remain in rest because resultant force is 0. And if the body is uniform motion, then the body continues in uniform motion. So balanced force means if a body is in rest or in motion, it will maintain the rest or motion. Okay, the second point is, we know that force changes size, direction and shape of the body. If balanced force acts on a body, then the size, shape and direction doesn't changes. So our second point is that this force doesn't change size, shape and direction of body. So the balanced force don't change the size, shape and direction of the body. Next, we will discuss about our second type of force, that is unbalanced force. What is unbalanced force? Just opposite of balanced force. So we can write the second point. Unbalanced force as if the resultant force acting on a body is not zero. That means if a body is in rest, if you will apply a force and the resultant force of the body will not be zero, then that type of force is called unbalanced force. Then this force is called unbalanced force. Okay, if the resultant force is not zero, if resultant force will be zero, then that will be balanced force, and the resultant force will not be zero, then the force is called unbalanced force. What happens in balanced force? The shape, size and direction of body doesn't changes, but in unbalanced force the shape, size and direction of the body changes. So our next point is, in this type of force the shape, size and direction of the body changes. That means if we consider balanced force, if the object is in rest or in uniform motion, then that will maintain that. But in unbalanced force, if a body is moving, if we give a unbalanced force to the object, then the speed or velocity of the object will increase. So this type of force is called unbalanced force, which can change the shape, size and direction of the object. Now we will discuss about Newton's first law. Newton's first law says that if a body is in motion, it will continue the state of motion, and if the body is in rest, it will continue the state of rest until and unless an external force is applied on it. Let us take an example that this is a body. If I will place this body like this, it is in rest. It will maintain its position, or it will continue the state of rest until or unless I will apply some force on this body. And if this body is in motion, it will continue the state of motion if I will not apply some external force to it. Okay? So we can write the law as, if a body is in rest, if a body is in rest, it will continue the state of rest or if the body is in motion, it will continue the state of motion until and unless an external force applied on the body. Clear about Newton's first law? A body will continue the state of rest or the state of motion until or unless an external force is applied to the body. So now we'll discuss about Newton's second law of motion. Second law of motion states that the moment of inertia of a body is directly proportional to the force applied on the body and will move in that direction where we apply the force. If this is a body and if I will apply some force in this direction, then the body will move in the same direction where I applied the force. Okay, so we can write it as, it states that the rate of change of momentum is directly proportional to the force applied and will take place in the same direction where the force is applied and will move in the direction of force. Okay, it states that the rate of change of momentum, this is the main part, rate of change of momentum is directly proportional to the force applied and will take place and will move in the direction of force. If I will apply a force in this direction to a object, then the object will move in the force direction. Okay, so now students, we'll discuss about Newton's third law of motion, the most popular law. Okay, Newton's third law of motion. So what is Newton's third law of motion? It states that for every action there is equal and opposite reaction. In opposite direction. This is the most famous law or most popular law of physics, that it states that for every action there is an equal and opposite reaction. Let us assume that this is a body, the blackboard is the body, and if I will slap this blackboard, if I will slap it, then the board is experiencing some force, right? I am doing an action, and the board is experiencing some force. In the meanwhile, my hand also experiences another force, and that is opposite in direction. If I will slap this board, then the board will experience a force from me, and the board will give a force to me also in opposite direction. Okay? So the laws of motion is over. In the next class, we will discuss about inertia. Okay? Thank you.